Welcome. In this session, we will break down the economics of cloud computing. We'll move beyond the basics to compare specific pricing models, explore how different service types incur costs, and identify strategies like reservations and hybrid benefits that can significantly optimize your cloud spend. To understand cloud pricing, we must first distinguish between CapEx and OpEx. In an on-premises data center, you deal with capital expenditure, or CapEx, where you pay upfront for hardware, electricity, and cooling, regardless of whether you use it. Cloud computing shifts this to operational expenditure, or OpEx. In this model, you rent computing resources like virtual machines and storage on an as-needed basis. This eliminates upfront costs and termination fees, allowing you to pay only for the resources you consume, which aligns your spending directly with your business agility needs. This flowchart visualizes the economic transition. On the left, under on-premises CapEx, large upfront cash flows into static hardware, resulting in a depreciating fixed asset. On the right, under Cloud OpEx, the flow starts with a business need that provisions a resource, resulting in a variable monthly expense. This illustrates how the cloud converts a rigid investment into a flexible operational cost. The core of cloud pricing is the consumption-based model. When you provision an Azure resource, the system creates a meter that tracks usage, generating records used to calculate your bill. For example, Azure virtual machines are priced per hour but billed per minute. Crucially, the state of the resource matters. If a VM is stopped, deallocated, the compute meter stops ticking, and you stop paying for the CPU, though you may still pay for the persistent storage disk. This granular metering allows you to run infrastructure efficiently by turning off resources when they are not in use. Pricing models differ significantly across cloud service categories. Infrastructure as a service, IaaS, charges for the provisioned server capacity, regardless of whether your application is busy or idle. Platform as a service, PaaS, offerings like Azure SQL Database or App Service often use pricing tiers, basic, standard, premium, which bundle compute and features into a predictable cost. Serverless or function as a service, FaaS, offers the most granular efficiency, charging only for the specific execution time and memory used, effectively costing nothing when idle. This diagram classifies the pricing logic. IaaS is defined by fixed capacity, billing per VM/hour. PaaS moves to bundled features billed by service tier. FaaS represents the ultimate abstraction, where billing is event-driven per execution. Understanding this hierarchy helps you choose the right model. IaaS for control, PaaS for convenience, and FaaS for efficiency. While pay-as-you-go offers maximum flexibility, it is the most expensive operational model. To reduce costs, Azure offers reservations and savings plans. By committing to use a specific resource type, like a VM or SQL database, for a 1-year or 3-year term, you can realize savings of up to 72% compared to pay-as-you-go prices. Reservations apply to specific resources, whereas savings plans offer more flexibility by committing to a dollar amount of compute spend per hour across various services. This model rewards predictability with significant cost reductions. This chart illustrates the time commitment aspect. The top bar shows the pay-as-you-go model running actively at a high rate for a year. The bottom bars show a reserved instance where you make a commitment for that same duration. In exchange for locking in that timeline, you unlock the discounted rate, highlighted in red, demonstrating the financial benefit of long-term planning. Beyond the service price, other factors influence your bill. First is geography. The same VM can cost different amounts in different regions due to local labor and power costs. Second is bandwidth. Typically, bringing data into the cloud ingress is free, but moving data out egress or between regions is charged. Finally, the pricing tier matters. Choosing a premium tier for a service like storage or networking often enables higher performance hardware at a higher cost. You must architect your solution with these hidden variables in mind. This breakdown shows how total cost is composed. It's not just the base service cost. The variable factors branch is critical. Under region, you see that selecting region A versus region B changes the rate. Under data transfer, we highlight the critical rule. Inbound is free, but outbound is billable. This visual reminds you to check where your data is going and where your resources live. For specific scenarios, you can leverage special pricing models. Azure Spot VMs allow you to use unused Azure capacity at steep discounts, making them ideal for interruptible workloads like batch processing, though they can be evicted if Azure needs the capacity back. Additionally, the Azure Hybrid benefit lets you use your existing on-premises Windows Server and SQL Server licenses in the cloud, removing the cost of the OS from your hourly rate. Finally, for development environments, dev/test pricing offers discounted rates on services to support innovation without production-level costs. This pie chart visualizes the impact of the Azure Hybrid benefit. The slice representing OS license cost is effectively saved or removed from your cloud bill because you are reusing an on-premises license. This leaves you paying only for the base compute cost and storage cost, illustrating how bringing your own license significantly reduces the total slice of the pie you have to pay for. To navigate these models effectively, you must use the right tools. The pricing calculator allows you to build a shopping list of resources to estimate monthly costs before you deploy. Once deployed, Microsoft Cost Management provides a dashboard to track actual spending and analyze trends. You can set budgets and alerts to notify you when you approach your spending limits, preventing billing shock. Finally, Azure Advisor analyzes your actual usage and recommends resizing or shutting down underutilized resources to optimize your spend. This sequence shows the life cycle of cost management. First, the user consults the calculator to estimate costs. Then, they deploy resources to Azure. These resources continuously send usage data to the cost MGMT system. Finally, if spending gets too high, cost management sends an alert back to the user, completing the loop of financial governance.